Hello everyone. It's been a while since I last posted, so it's good to be back. Also, if you've reached so far down the playlist, I would request you to consider subscribing, as it also motivates me to make more videos. So get on to the next problem. So you have 12 identical balls. One of the balls is heavier or lighter. You don't know which one. Uh, Using a balance which can only show which side is heavier or lighter, we have to determine which is a defective ball with three measurements. So I went through this problem and I found a bunch of ways to explain this, but I honestly feel that the way mentioned in the textbook is the probably one of the best ways to understand this the tree diagram. So I'm going to be using that diagram itself and help you understand how this problem is going to be solved. So let's say we have three cases: one, two, three, four, right? 5, 6, 7, 8. I think as a bonus part, let's also look at the case which is not mentioned in the textbook, right? Which is shown with a question mark. I think that would be interesting. So these two sets, this would be A, this would be B, and C is 9, 10, 11, 12. Okay, let's say. Let's say if these two groups were equal, right? Then you know for a fact that the defective ball will be in group C. So what we're going to do is take up group C, 9, 10, 11, 12. But if you were going to put this on a measuring scale, let's say 9 and 10 versus 11 and 12, and in suppose, let's say one of the sides is heavier, right? Let's say 11 or 12 was supposed to then combined come out to be heavier than 9 and 10, you really can't make much out of it, because what are you going to do with that information? You don't know. You are not given if the defective ball is heavier or lighter. Let's say you already knew which ball is let's say you already knew that the defective ball is heavier. Then, well, we could have taken this set, and if let's say 11 or 12 were heavier, we could have said measured that again, 11 versus 12, and in the third set you would have gotten to know. But if you're going to take this set and measure it without knowing if the defective ball is heavier or lighter, it's not going to lead us anywhere. So instead of taking all four balls with which whose status we're not sure of, let's replace one of the balls with a ball whose status we're sure of. Let's replace 12 with 8, because you know for a fact that 8 is a ball that whose weight is equal to the ideal weight. And after we take this as a set, let's go and look at the cases. Let's say if these were equal, right? 9, 10, 11, are then equivalent to each other, so they're not the defective balls. You know now that the defective ball is the one which is outside. It could be 12, but you don't know if it's lighter or heavier than the rest. So for to know that, you would take a ball which you know for a fact is not defective and measure it with a ball that's measure that against it. And in this case, you have two cases. If let's say 8 greater than 12, you know that 12 is the lighter ball. If 8 was less than 12, you know 12 is the heavier ball. That is one case. And if you can see, as you can see, this is the first layer of measurement, this is the second layer, and this is the third layer. You're just finding it out in three measurements. Okay, let's look at the other case. What if the trio of the duo of 9 and 10 are heavier than the duo of 8 and 11? In that case, you again have a host of cases, either 9 or 10. 9 is heavier, or 10 is heavier, or 11 is lighter, because you know for a fact that 8 is the ideal ball. Let's again measure. I would say we can measure 9 and 10. Why not 9 and 11? Well, you can also measure. There's no point in measuring 9 or 11, right? Because the cases dictate that we don't know if 9 is heavier or 10 is heavier. But we know if we are going to measure 9 and 11, given this case is already in question, so 11 is going to be lighter than 9 anyway. So we are not really finding out much from that. So we're going to measure 9 and 10 because we don't know which one is heavier, right? If they're equal, 11 is the ball and it's lighter. If 9 is heavier than 10, given that the side was already heavier, you know for a fact that 9 is heavy and that's a defective ball. But let's say if 9 is lighter than 10, because the combined side is greater than the other two ideal balls, you know for a fact that 10 is the heavier ball. Okay, let's look at the third case in which 9 and 10 combined are lighter than 8 and 11, and because 8 is the ideal ball, so either 9 is lighter, either 10 is lighter, or 11 is heavier. Again, you're going to take 9 and 10 because you know for a fact taking 9 or 11 or 10 or 11 won't make sense, because it will always show that 11 is heavier than 9. You're not making much out of it. Here, if you measure 9 and 10, if 9 is equal to 10, then you have 11 as the heavier ball. Let's say if 9 is heavier than 10, then you have 10 as the lighter ball. But if 9 was lighter than 10, you have 9 as the lighter ball. So this is the case for which A and B have no defective ball, and it's the group C that has a defective ball, and these are the various possibilities. Okay, now let's look at the case in which group A is lighter than group B, right? In this case, what we're going to do is we're going to take four balls. One, again, we're going to take, yeah, you can have, because 1, 2, 3, or 4 is lighter, or 5, 6, 7, and 8 are heavier. Each, any of these balls are heavier. So again, we're going to do what we did in the previous group. We're going to take an ideal ball. In this case, let's take ball number 9. It's the closest. You know that ball number 9 is ideal. And the other cases, let's take 1, let's take 2, let's take 1 from this group, 5. And let's do the same thing from the other side. Let's take 1 from this group, 3, whatever's next. Let's take whatever's next from this group, 6. Fine. Okay, let's say we're going to measure these two. We're going to put this here, put this here. Let's say they're equal. What do? If they're equal, then you know that what is left out. If they're equal, we're leaving out these numbers. We're leaving out 4, we're leaving out 7, we're leaving out 8, right? If they're equal, right? If they're equal, you know for a fact that either 4 is lighter or 7 or 8 are heavier. Why is that? See, in this case, we know that A is less than B, and the balls that are left are these, right? A, 4, 7, and 8, which were taken out. Again, here there's no point in measuring 4 and 7 and 4 and 8. For the third measurement, you're going to have to take 7 and 8, because that's where the confusion is. If you're going to put 4 against 7, it's always going to show that 7 is heavier, 4 is lighter. If you're going to put 8 against 4, it's always going to show that 8 is heavier and 4 is lighter. So we're going to have to take the two balls where there's a confusion lying inside. And if 7 is equal to 8, you know that 4 is the lighter ball. If 7 is heavier than 8, then we saw that this was on the 7 and 8 were making the entire group look heavy, so it's 7, that's the heavier ball. If 7 is lighter than 8, then it's 8, that's the heavier ball. This is one of the cases. Now let's look at the other case. Other cases in which let's say 1 to 5 are heavier than 3, 6, 9, and you know that 9 is the ideal ball. So in this case, you will have the case that let's say we'll have the case that, okay, this combined is heavier than this, but given the initial condition that B was in total combined with heavier than A, you know for a fact that 5 is either the heavier ball. And let's see, these are group representatives of group 1, group 2, the group A, group B, group A, group B, group C. C is ideal. You've taken a representative of group B. Now we have to take representatives of group A and figure out. And the only representative of group A on the right hand side is this. So either 5 is heavier or 3 is lighter. You want to measure 3 and 5. If 3 is lighter than 5, no, not 9 here. It's going to be 5. Oh, wait. No, actually, you can't take 3 and 5, because you know definitively what the case is. It's 3 and 9 only. 9 is the ideal. But if let's say 3 is lighter than 9, you know it's 3 lighter. If 3 is heavier than 9, if 3 is equal to 9, then 5 is heavier. 3 can't be heavier than 9 at all, because that's out of the realm of possibilities. Let's take the third case in which 1 to 5 is lighter than 3, 6, 9, right? And let's take the first piece of information also, that 1 to 5 was actually the 1, 2, 3, 4 was lighter than 3, 6, 9. In this, the representative of the first group, these are the representatives of the first group, the second group, first group, the second group. You know 1 to 5 is lighter than 3, 6, 9, right? So either 1 or 2 are lighter, or what's in group B? 6 is heavier. We're going to again measure 1 or 2. Measuring either of them against 6 won't make sense, because it's always going to show that 6 is heavier or 1 or 2 are lighter. When measuring this, if they're equal, you know that 6 is the heavier one, it's the odd one out. If 1 is less than B, then you know 1 is the lighter one. If 1 is greater than 2, 2 is the lighter one. So these are all the cases. Let's look at the third case, which is not mentioned in the book, which says, what if 1, 2, 3, 4 are heavier than 5, 6, 7, 8? Let's look at the case for now. Well, that means that either ball 1, ball 2, either of them are heavier, or 5, 6, 7, 8. One of them is lighter, right? Let us once again go through these possibilities. Let's take something from group 1. Let's take a couple from group 1, right? Let's take a couple from group 2 as well. Okay, yeah, we've taken two representatives of this side. Let's bring one from third side, 1 to 5, and 3, 6, 9. 3, one from this side, one from this side, and one neutral. See, this is how the split is going to be: A, B, A, B, neutral. You're gonna have to use this algorithm. You're gonna have to have a representative of each group on either side, and then a representative of the neutral group on either one of those sides. And now you've gotten to know that this is heavier than this, right? This is heavier than this. Sorry, this is heavier than this time. Yeah. After this, again, we're going to look at three cases, right? What if they're equal this time? First case is they're equal when you're measuring them. And previously you've been told that this group is heavier than this group. So that what does that leave you with? This group was heavier than this group, but now it's becoming equal, right? Just think of it for a minute. This is 4 here. If these two are equal, what did we leave out? We left out 4, we left out 7, if we left out 8. And you know, if they're equal now, you know for a fact that either 4 is heavier, the heavier one, or 7 or 8 are the lighter ones. And again, as we've seen this multiple times before, there's no point in comparing 4 and 7 or 4 and 8, because 4 is heavier than 7 or 8. That's already a given. What we need to compare is 7 and 8. In this case, if they're equal, then 4 is heavier. 4 is heavier. Why am I writing 4 like that? Yeah, 4 is heavier. If the 7 is greater than 8, then 8 is the lighter one. Am I getting that right? Yeah, 8 is the lighter one. But if 7 is less than 8, 7 is the lighter one. These are the three cases. Let's look at the other case in which 1 to 5 are heavier than 3, 6, 9. Okay, in this case, let's say we have this case. You know they're greater, and your previous information dictates that 1, 2, 3, 4 is heavier than 5, 6, 7, 8, right? So just think of it for a minute. What are you left with? You know that 9 is neutral for sure. Sorry, I used the wrong tool. 9 is neutral, so it's out. And you have representatives of group A, group B. Sorry, group A. These two are group A. This is group B. Let me write that down neatly so it's clear. 1, 2, 5. See, group A, group B. And this is heavier now. Group A, group B, neutral. Okay. You have a piece of information that this is heavier than this already. On top of that, you're being told that 1 to 5 are heavier than 3, 6, 9. So you know for a fact that if this is heavier, right? So 1 or 2 are heavier. 5 can't be heavier. 5 is on the lighter side already. 5 can be neutral, that's all. Or what's from the second group? What's on the second group? 6 is lighter. Why is that? See, this is already given that these are heavier, and now that this is becoming light. If 3 was a defective ball, it would have tilted it in the other way. But because 1, 2, and 5 are becoming heavier, you know, either 1 or 2 are heavier or 6 is lighter. And again, as we've seen numerous number of times, there's no point in comparing 1 or 2 with 6. What we're going to compare are 1 and 2, right? If 1 and 2 are equal, 6 is lighter. If 1 is heavier than 2, 1 is the heavier one. Sorry, if 1 is lighter than 2, 2 is the heavier one. If 1 is heavier than 2, then 1 is the heavier one. This is the answer that you have. Let's look at the third case in which 1, 2, 5 are lighter than 3, 6, 9. And you're already told that 1, 2, 3, 4 are heavier than 5, 6, 7, 8. Okay, and these are A, this is B, this is A, this is B, this is neutral. And you're being told that this is heavier now. Knowing that A was already heavier, you know the 3 is the only one that could make it heavier, or something is lighter. What is lighter? What is left? 5. 5 is lighter, or 3 is heavier. What you're going to do? You can't measure 3 and 5. It's pointless. You're going to always see that 3 is heavier than 5. You either take 5 or you take 3. Let's take 3 in this case. We're going to measure it against 9, right? Because it's either 5 is heavier or 3 is lighter. Let's say if 3 greater than 9, 3 is heavier. If 3 less than 9, if 3 is greater than 9, you know 3 is heavier. If, let's say 3 was less than 9, then it would be 5 is lighter. Does that make sense? Am I telling the other way around? 3, 9. Oh, sorry, this can't be light greater than or equal to. That's my bad. So what's going to happen? You see, either 3 is heavier or 5 is lighter. If they're equal, well, you know for a fact that 5 is the lighter one. But what if 3 is greater than 9? You're going to know that 3 is the heavier one. If you had taken 5 and 9, in this very case, you would have these two options. If they are equal, well, then 3 is the heavier one. But if 5 is less than 9, then 5 is the lighter one. Just alternate case for this very measurement. So these are all the cases that have been covered, and I hope it's very clear, and we've shown how in just 3 measurements you can find out which ball is heavier or lighter and the exact property of that also. Thank you for now.